Hello guys, welcome back to Code with Nani channel, and today we're gonna discuss the lead code problem of the day, which is count the number of good subarrays. So you are given integer array nums and integer k. We need to return the total number of good subarrays of nums. So a subarray of array is good if there is at least k pair of indices such that array of I equal to array of j and index of j should be greater than index of I. Okay. A subarray is a contiguous non-empty sequence of elements within an array. So what they're trying to say is, suppose let's take 1 1 1 1 1 example, nums equal and k equal to 10. So we need to return the total number of good subarrays in which it should have at least k pairs of nums, in which at least it should have k pairs. So what is a pair? Pair is a set of two integers, okay? I, j, and j should be greater than I. Another condition is nums of I should be equal to nums of j. Basically, they were saying we need to find another index in which the value of I and j should be equal, and we need to figure out 10 pairs, okay? Suppose if you take this example, 1 1 1 1 1. So zeroth index, first index, second index, third index. So how many pairs that exist with the same value 1? So you can pair with zero index with 1. You can pair with zeroth index 2. As this is j, this is I. J is greater than and I, and nums of j is equal to nums of I. See, both the values are equal. Anyways, it's an unique. It's not a unique array. It's the same. It contains the same values, right? So you don't need to check the values. Anyways, all the values are equal. Okay. So and we can pair with 0 with 3. We can pair with 0 with 4. So total 1 2 3. We have a 4 here. And now start with the 1. 1 can be paired with 2. There might be a what you can say, you cannot say it's a duplicate. Anyways, the condition itself nums of I should be equal to nums of j, right? So you shouldn't consider it as a duplicate, okay? Because here, check out the indexes. Now we are pairing with first index with the second index. It is a unique set of k, right? Unique subarray, right? Unique k pair of indexes, right? So now 2 can be paired with 3. Sorry, we are checking with 1, right? So 1 can be paired with 3, 1 can be paired with 4. So now here we have a 3. Now check for 2. 2 can be paired with 3, 2 can be paired with 4. Now here is 2 indices, and 3 can be paired with 4. So that is the final set of pair, final pair, and that is 1. So if you add all the things, what is the total number of pairs that you have that satisfies the condition is 4 plus 3 plus 2 plus 1, which is 10. So if you consider the whole set of array elements, then you can able to figure out the k pairs of indices such that it satisfies the condition. Okay, then we should include all the elements, so that will be a subarray. Even the whole array can be a subarray of that array, right? So what will be the count? Count is 1 because we only find the entire array as a subarray to this array that satisfies the given condition. Okay, that's why the count is 1. So that's what we return. Suppose if you take this example, if you take this example, 3 1 4 3 2 2 2 4. Okay, so how many elements? And the k is 2. So let's just understand the intuition with this. So what you can try to find is figure out figure out a particular element, figure out with a particular element which causes the frequency by 2. So in anyways, what they are trying to say is we need to find nums of I equal to j. Suppose if you can able to figure out the frequency of element, frequency of an x, then try to find how many pairs that it will get. Suppose suppose if the frequency of an element x equal to 4, so how many pair that, suppose we have a 4, okay, suppose x. So now the frequency of x is 4, okay, and how many pairs that it can generate with this frequency. So this x can be generated, can be tagged with 3 other elements as well. So for this x it is 3, and for this x it can be tagged with 2 other elements, 2, and this x it only can be paired with one element, and for this x it doesn't have any other elements to be paired with. So if you take care with x equal to 4, how many elements that it can be paired with? 6. Now we will check whether this 6 is greater than or equal to k. If it is greater than or equal to k, suppose as here, as here the given value k is 2, we need to figure out a 2 pairs, right? Suppose if you carefully observe, is my expression is true? 3143 to the 4. Yeah, okay, 2 pairs. So, so then what you can try to do is, suppose if you can figure out, suppose let's just take this as entire subarray. So it has 2 pairs, which is 3 comma 3 single pair and 2 comma 2, and suppose if we have another elements as well. So this subarray satisfies the condition with saying k is equal to 2, which means at least it has a 2 pairs. So it has a 2 pairs. So how many subarrays it can be formed? Okay. So just think, with this array will be counted as 1 plus, and we can add this element as well. That can be a subarray for this particular array. So that will be 1, and you can even add this as well, but you cannot skip. If you skip, it doesn't become a subarray, it will become a subsequence. So you need to attach that element. We cannot skip in between the elements, it should be a contiguous part. So you can add 5 as well, plus 1, plus you can add 6 as well, plus 1, you can add 7 as well. So if you have a 4 elements, the 4 subarrays we can get with that. Okay. So the what we can try to do, if the position is r here, suppose if we are ending at rth position here, position is r, and what are the remaining elements? N minus r plus 1 will be the remaining elements. So remaining elements equal to n minus r plus 1. So, and we need to, sorry, what will be the remaining elements? N minus r remaining elements equal to n minus r minus 1 element. And as you can see, the total entire element will also be a part of this count, right? So just add it. So remaining elements will be n minus 1. So remaining the subarray contribution. So that subarray contribution will be the n minus r. Okay. So that only we need to care about. So just if you if you follow me until here, you'll get to know like what approach we need to use in this particular solution. As you can see, we are using sliding window. We will slide through the nums of array. Whenever we figure out a nums of a current element, if it until now, if we crosses the k, then what we need to do is we'll simply add the total count of the subarray that can contribute, and we will start decrementing the left pointer. We'll start decrementing the left pointer. Still, if we find its count is greater than or equal to k, we'll add that element as well. And if it doesn't satisfy the condition that like count is greater than or equal to k, then we'll start incrementing the right pointer. Okay, so you can ask me how can we count it? Okay, count the count the pairs that it can contribute to. Suppose we have a four ones. Okay, so what we can try to do is, now the rth position is here. What you can do is count plus equal to frequency of, suppose this is the next element, frequency of x. Now, uh, as of now, the frequency of x is 0. Suppose take x equal to 1. Now the frequency, as we are in the first index, now frequency of 1 is 0. So the count is 0 here. Then we will increment frequency of x plus plus. Okay. Now at this point, okay, now the r is here. And the frequency is 1. And the frequency is 1. Now if we add to the count, now the count becomes 1. Okay, and we will increment frequency as 2. Frequency of x equal to, now here x is 2, and now the r is here. Now what is the frequency of it? What will be the frequency of the count? Count is 2. Now we will add with this, and now the count is 3, and then now the frequency will change from 2 to 3. And in the last iteration, add to the previous count. So 3 plus what will be the current frequency? What will be the current frequency? 6. Now the frequency becomes 4. See, as you can see, for the previous example which I did for the 4x, what will be the pair count? That will be the 6, right? Because you can pair this element with the 3 indexes as well, 3 plus. We can pair with this element with the 2 indexes as well, 2 plus. And this can be only paired with 1. No, no, let's check once again. This can be paired with 3 indexes, and this can be paired with 2 indexes, and this can be paired with single index by 6. Yeah, 6. So that's the exact count that we get. So we can use this approach to count the frequency, to count the pair count. And if the pair count is greater than k, what we will try to do, if the count is greater than or equal to k, pair count, then what we can do is simply add with answer plus equal to n minus r, which gives you exact count of a subarrays. Then what we need to try to do, then we need to subtract, okay, count minus equal to minus minus of frequency of nums of L. So what is does is, we are subtracting the frequency of that element with the count, because so suppose 4, right? And for the 4 values, so 1 2 3 4. So for the 4 values, we are getting the free count as 6. Okay, and we are start decrementing from the left side. Suppose if you want to remove this, so how many counts that these 3 numbers can generate? One can be paired with it, this one can be paired with 2 other elements, this can be paired with another paired with 1, so total 3. So as you can see, suppose if you carefully observe before, the last count is added by 3, right? Which is the frequency, which is the, now the current frequency is 4, and we are decrementing 1 1. Subtract that frequency, right? Subtract the frequency nums of I minus minus, because we are reducing one frequency. Okay, so that reduces by 1. Now the frequency becomes 3. Okay, but still the count is 6. Subtract that with the this frequency. Why we are subtracting? Now the count becomes 3, which is exactly equal to this one. So why we are subtracting 6 with 3? Because this integer can contribute to three other integers as well during the pair count, right? So we need to subtract with total all three elements. Now the current frequency is 3. We need to subtract that with the total count, including that one will be 6. But that particular element can contribute to three other elements. If you subtract with the three elements, we can entirely remove the pair count of that particular integer, right? So that's what we are doing. Just reduce the frequency and reduce it from the count. So then we can get the total count of this particular window, which is after incrementing the left point. Okay, let's just jump into the code. You'll get clarity around the question. So just increment source. So as you can see, I'm just initializing the n to in order to maintain the frequency. I'm using the unordered map. This is the long answer, as it can lead to outbound condition. We are using a long answer, and the count, which is to count the total number of pairs, right and left pointer. Okay. Now, while right pointer is less than or less than n, what we are trying to do is count plus equal to frequency of nums, which is we are we are adding the frequency of the previous occurrence to the count to get the total pace, or you can even add it like this. Okay, now I'll get to know. Then increment the count. So through this count you'll get the total number of pairs. Okay, so this count I'm directly returning as a plus plus, so that it will be post increment, right? So after adding into the count, then it will increment. That's what I'm doing. So this will get the count of the count of this particular nums of r. Okay, so suppose if count is greater than or equal to r, what we are trying to do, answer plus n minus r, which will give you the total contribution of this particular pair, um, with the subarrays, how many subarrays that it can be generated with the right side part of the array. Suppose if the right side part has three elements, then this subarray can contribute to three elements. That's what we're doing. And in the end, what we're trying to do, first reduce. So in simpler words, I wrote it directly, but you can write in this way as well. Reduce the frequency of that particular element. We need to reduce its count as well, right? Reduce its count as well. As I told you earlier, if you're reducing the frequency and subtracting with the total count, it will reduce all the count of this particular element that contribute to the pairs of indices. Then increment the left pointer and increment the right pointer, and in the end return answer. Let's just submit the code. Voila, it's submitted. And regarding the time and space complexity of this solution, the time complexity will be of n log n, because we only iterating from uh, right pointer, and the left pointer at most it can run until log n. And what will be the space complexity? It is of 1, because we are not using any other additional data structure. And that's it for today video, guys. So if you like my explanation, do like the video, subscribe to my channel, and hit that bell icon so you'll never miss any notification from my channel. And if you had any queries regarding my explanation or regarding the code, do put it in the comment section. I'll help you out, guys. And that's it for today video, guys. Thank you. Tata. Bye. See you tomorrow with a great video. Bye bye.